Okay. So now we are going to be looking at this example whereby they say show that x squared minus 6x plus 16 has a minimum value of 7. Most importantly, show that by completing the square. So the most important part out of this statement, honorable member, is that what they want you to do, it is to show that the whole of this thing, that quadratic expression, it has a minimum value of 7. Can you see? So this should be connected to what we previously did, but it's like you are now doing it in reverse, whereby you already know what you are working towards. You are working towards having a minimum value whereby that value is 7. So that means as you work it out, you should get to a point whereby you are having a minimum, I think, yes, it is that one where we are having a positive a value. And then you should be having your Q value being a 7. Most importantly, honorable member, I want you to be aware of something very much important. So you are having x squared. In this case, you are having that b value plus 16. So you cannot say your maximum value is that because of you having this thing. So this thing, the b value, it has to be removed. Once that is removed, and then you will remain with that q value. So in other words, you always want to have your expression in this type of a format plus q. Yes, in this type of a format where it does not have that, then in that way you will deal with it decisively. So that means you will need to convert it from this state to that state, and the only way that we know at this point it is by completing the square. So that's why you cannot conclude to say this is the minimum value that they are talking about. You can't do that because of you having that. So that means you need to get rid of that, and the only way you can get rid of that, that's if you complete the square. Yes, something of that. So I'm sure by now completing the square is just a 2 minutes thing. So you know, most the most important part is for you to take that coefficient of x, you multiply it by half, which means it is half where we multiply that coefficient of x. And then what you do from there, you just square it. So in other words, it's like we are taking, what is the coefficient of x? Is it not 6? So in other words, it's like we are taking half of that -6. Nah. And then from there, we will square that. What will that be? Will it not be -3 inside? It will be -3 squared. And when you punch that, or when you work it out, it ends up being 9. So in other words, it means that expression of x squared where we minus 6x and we plus it by 16, it is just the same as you having that -6, whereby you remember most when you complete the square, you have to plus that same value and you need to still minus it, and then you therefore have 16. So the main purpose of you going through that process is just for you to determine that, because with you determining that, indirectly you have dealt with this part, whereby that part, it is therefore the same as x minus 3 squared. And then now you still have your -9 that you have to plus it by 16. Trust me when I say that -9 plus 16, it is the one that gives you +7. Therefore, we've just shown that indeed the minimum value is 7. So The honorable member, in this process, the most important thing that we are working towards is actually getting that value. So this value can be a minimum or a maximum, and it is dependent on this for us to know whether it is a minimum or a maximum. Very much important, honorable member, on that one. I would like to try and be practical by doing this example so that you will have a better understanding of how we use mathematics in real life in terms of the maximum and the minimum. So I might not go too deep, but definitely when you get to varsity, let's say you'll be doing engineering or whatever the case may be. I'm not really sure about teaching, but definitely you will be dealing with some more complicated problems that will need you to apply your mathematical knowledge. So without wasting much of our precious time, in the event where you are given this statement where they say a farmer wants to fence off his cattle within a rectangular area. So he has 18 kilometers of fencing. That is the statement, honorable member. So there is a farmer who wants to fence off his cattle within a rectangular area. Very much important. So you've got 18-kilometer fencing and you want to fence your cattle in a rectangular area. So now, number one, it is a question whereby they say, show that y it is equals to 9 minus x. Remember, it is a rectangular shape that you want to form. So that means the other side is being referred to as x, and then the other side is being referred to as y. At the end of the day, we want that shape to be a rectangular shape. What we just don't know is that what is the value for the side of x and what is the value for the side of y. Because they've got different letters, it means they are also different in values. They do have to be different because it's a rectangular shape. If both sides were the same letters, it would mean it's a square. But because it's not a square, the other side is x, the other side is y. So here they just want you to show that the other side, being the y side, is the same as that. So as a mathematician, you should be in a position where you will therefore say, okay, in that case, if it's a rectangular shape will mean this side, it is also x, and that side, it is also y. That's what we know about a rectangle, honorable member. So what should come to your mind? It is the perimeter calculation. You say, when it comes to calculating the perimeter of a rectangle, we will take side 1, we plus it with side 2, we plus it with side 3, we plus it with side 4. Yes, something of this nature. Honorable member. So why approaching it that way? It's because you already know that the total length of the fence that is available is 18 kilometers. That we know most. To say the farmer has 18 kilometers of fencing. So that means we have to make sure that that 18 kilometer, it is the one that is able to fence in a rectangular shape. So that means that 18 kilometer must do this shape of that side, that side, that side, that side, with that side being equals to that side being equals to that. So therefore, it means you will therefore say 18 being the perimeter of that shape equals side 1, if we say it's x, maybe side 2 can say y, side 3 will be x, and then the last side being y. So we end up having this and that. Definitely, it looks like we are having 2x there that you will plus it with 2y. Can you see? You are working out the like 10 terms. Yes, something of that. But wait, you can take out something as a common factor there. Then you end up having that. Yes. And then you can remove that by dividing that on both sides. So you end up having 9 here, which is equals to x plus y, because that cancels with that. Therefore, remember what the question said. They wanted you to just show that which side? Side y is equals to 9 minus x. Indeed, if you take that x to the other side, you end up with y there. So that means side y, it is indeed equals to a 9 minus x. And that should be the end of it, with you showing that. Okay, let's not waste time and continue. I've got 2 more questions that I would like to take you through. And then this one, being the second one, it says, write a formula for the area of the farm in terms of x. Remember, based on our calculation, honorable member, we just discovered that, okay, this side, it is x, but this one, it is 9 minus x. Did we not just discover that? We did discover that, honorable member. We did discover that because this is proof that indeed that side is equal to that. For that reason, we will therefore say what we know about the area of a triangle. We just know that it is the length where we need to multiply by the breadth. So from that original shape, what we know is that the other side, it will be whatever letter, the other side will be a different letter. In this case, they use letter x and y. So that means it will therefore be side x that we multiplied by side y. And what we know is that side y is the same as 9 minus x, which means we end up having 9x minus x squared. This being the area of that honorable member. So this is like the formula for calculating the area of that rectangular shape. As an example, honorable member, which would mean, for example, if you want to, and maybe let me not say much, because you see now I'm going to be teaching you some stuff that they teach at a tertiary level. Yes, some stuff that they teach at tertiary level, but let me not confuse you that much with all of that information, honorable member, or the member who is honorable. Okay, so let's maybe continue to the next question. We've just done that. Is done. So now they say, what is the largest rectangular area that can be enclosed with the 18-kilometer fencing? It's like they're saying that 18-kilometer fencing, what is the maximum area that that fence can make? It can only make a maximum area, honorable member, because if it is this long, whether you make it a triangular shape or a square shape or whatever type of a shape, it will just cover a certain maximum of area because of its limited dimension. So now that's when you use your knowledge of completing the squares in order to determine what? To determine the maximum area. That's how you work it out, where they say, what is the largest? So the word largest goes hand in hand with the minimum. So otherwise, in other questions or in other types of questions, it could be that they talk about a minimum to say, for example, what is the minimum? Something of that nature, honorable member. I'll just find out if I can create more of this type of questions, or maybe as we do some exam type of questions, I think we should come across such questions where we might need to work it out. I'm just saying, for example, in case if now they talk about the what is it, the minimum, they might use a different way, just like they are saying what is the largest. Yeah, something of that nature. So what is the largest rectangular area that can be enclosed with the 18-kilometer fencing? So can you see we are back to what we were discussing, to say that means when we talk about the maximum, for the maximum, it's a negative a value. Yes. For the maximum, we must be having a negative a value as we work out our thing there. And then from there, we will therefore have that, let's say, plus v. Let me not use q and then use v, because that v, it is the value that we are looking for. So that means, the honorable member, because it is the area involved, that's why we are going to use that formula for the area, so that we will manipulate it such that it will give us a maximum value. So how are we going to do that? So let's see. Let's just rewrite it nicely in the standard format. So let's say area formula. The formula for the area, we've just calculated it. It is that. Hope you agree with me on that one. So to rewrite it nicely, we will write it as negative a squared plus 9x. In that format of ax squared, you see it has a plus b plus c. Can you see? So now the problem here is that it has this. That is why we will need to do the thing of completing the square, so that we remove that and it is in that type of a format. In that way, we will be able to easily work it out. So that means we are forced to now complete the square. So how are we going to do that? You know, most we've just done it. But before we can even complete the square, let's see. I'm just trying to verify something there. Okay, yes, then it's fine. Let us take out that negative, so that we will easily be able to do our thing there. So if we take out that and we said we are having negative, that means into we end up having a x squared minus 9x, and then we do that. So we are just being strategic, honorable member, because we know that we need our a value at the end of the day to be a negative a value. That's why we are thinking ahead and already taking out that, because the negative a value is associated with a maximum value. So now let's continue with the thing of that. Yes, I'm pretty much sure that by now you would agree with me to say it will definitely be that x squared, where we will minus that. And what are we going to do? Remember, we are going to say half of that squared, isn't it? Which means half of negative 9. It ends up being negative 9 over 2 squared. And then we have to minus that exact same thing. Hope you would agree with me on that one as we complete the square. Definitely, we end up now having this. What will that be? It will definitely be that x squared, where we are minusing that 9 over 2 squared. And then let's see, definitely minus, what is 9 squared? Is it not 81? That is 81. I've done too much of mathematics to know that 9 squared is that. So you might be wondering to say, okay, what's happening to that negative? It is the one that disappeared, because squared means 2 of exactly the same thing. So it's like you are having negative 9 over 2, and again negative 9 over 2. So that times that is 81. That times that is 4. That negative times negative, it becomes positive. So this negative that I've written, it is that one. Just be very, very careful of that. Very, very careful of that. Okay, with that being the case, we can now multiply that by that and also by that. Trust me when I say we end up having negative x squared minus that. Minus that 9 over 2 squared, and that negative multiplying with that, we end up having that as a positive, that 81 over 4. So now can you see it is in that format where we can easily interpret it to say the coefficient of this thing, it is that negative invisible one. Therefore, this has a maximum value of that. Can you see? Let me go back to that and say, you see, it has a negative coefficient, which means it has a maximum value of that. In this case, what is that maximum area value? It is that. So as you conclude, you will therefore say the maximum area that can be enclosed is that 81,4 kilometer squared. Yes. Yes, 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 yes. As a decimal, what is that? Let's see. 81 divided by 4, 20,25. Yes. So that means that fencing of 18 kilometers long, it can create a maximum area of 20,25 kilometer squared. It doesn't matter this time around. It doesn't matter whether the shape, it is a square, it is a rectangle, it is a circle, or it is a triangle, whatever the shape that you can think of. At the end of the day, what we know is that it can only create a maximum area of 20,25. Can you see? So why is this type of a calculation important, honorable member? Imagine if you were building a wall, or if you were constructing a wall and you want to now gather all the material. You will therefore know that, okay, if I have got this much of material, it can create a maximum area of that. Then if you want to go buy a paint or order a paint, then you know that the paint that I'm ordering, it has to cover this much of an area. If you want to hire people, you will say, I want enough manpower to build this size of a wall. Then an experienced contractor will say, okay, how long do you want it to be done? I want to finish it in a week. Okay, if you want to finish it in a week, then you will need this many people, because it takes, for example, maybe 1 hour to do this much, and they can only work 8 hours. So in 8 hours, you would have completed this much. And then if you multiply it by 7 days, then it will be this much of work completed. So that's how you quantify using mathematics, honorable member. It's an application of mathematics in real life, to say these things that you are learning about, completing the squares and all of that, this is how you apply it. Maybe let me not go much or deep into all of that, and just say until